Alright guys, so here we are. This is the 14cc GX160 cylinder head. As you can see, I haven't really started on it yet. I basically just started on it by doing some rough marking out. Some kind of bad news. The original seat setup we wanted to do is not going to be able to work. It's basically going to be one or the other. We can either put in the larger intake seat or the larger exhaust. This customer wants to do 32/28. They can fit. The only problem is the machine shops in my area that put seat in don't have the tooling small enough to put in this seat. This might be a problem you guys run into in your area, but the 32mm seat we have the ability to put in. So I've called the client, gave him this information, and what we're going to be doing is just sourcing another intake exhaust valve. This is usually a 24mm, so we'll probably go into a 25, cutting this seat a slightly bit bigger. In these small heads, these are very small heads. Their ports are extremely small. They're very hard to work in. Going any bigger with the seats out of a stock seat, you start really getting into a area of an extremely thin seat. Thin seat could thin from this dimension to this dimension, thin this way. These are only a 1/4 inch seat from top to bottom, and which is small depth wise, but which is good. But the thickness of the seat this way is very thin as well. So we're probably going to end up putting in a 32mm seat. Anyhow, what I do want to say is, if in fact you do get these, on this cylinder head, this is like the worst case of valve shrouding I've ever seen. Usually these seats have bad valve shrouding, but if you look, the lighting right now is terrible. It's just the time of day. If you look, say over here, this, I measured it and it's 128 thousandths. And if you look, that carries all the way around this valve. I mean, it is just solidly shrouded. When the valve sits in it, it's literally sitting way down in the cup, and the exhaust valve is even worse. So if you guys are using these 14cc heads, if you don't have the ability to get in there with something to remove that ridge, these are an extremely bad mod. I do not like this head at all from what I'm seeing. We are going to be moving forward with it. If you notice the blue areas, like all up here and all down here, that's how much has to be filled with weld to get the head to 10 cc's. Our goal compression ratio is 18:1. His goal compression ratio, I'm sorry, would not be anything I would recommend for anyone. But 18:1 compression ratio on a 212 bottom end, you need 10 cc's in the head, and then your head gasket, which is like 2.5, 3 cc's. So that being said, trying to get a head down to 10 cc's, what the problem is going to be presented with this head is there are a lot of problems with this design. One, putting in this bigger valve sounds like a great idea. Put in a bigger flat valve, you're able to increase your flow. The only way you would not be able to increase your flow by putting in a bigger valve is if when you put that bigger valve in, the valve is shrouded. If you can see this outside blue circle, that's where, just roughly, place the new seat on and just traced roughly with a Dicom marker. When I trace that, as you can see, it's up into the welded area that we're going to have to get into. So basically what this represents is going to be the inside of this line here is going to be the valve. So it's literally going to have from here all the way to here, it's going to be sitting down inside of a cup. Now, as this seat sits now, if it just had this little ridge like this, I would want to remove it. The head I am being asked to build now goes against every aspect of engine building I recommend. Now, the fact that I'm filming this so you guys can see the good and the bad of engine building. Now, when I put this valve inside this head, this valve is going to be extremely shrouded. If this is filled with weld here, and it's filled with weld here, when that valve sits in there, it's going to be inside of a cup that's as deep as the cylinder head. And the only way the air is going to be able to come out of that valve when it opens is right here. And it has to come up and then go out that way. So it's literally just going to be this little passageway between the intake and the exhaust valve. So we're going to move forward with it. I have a lot of people out there that text me that really want to see this build. They want to see this setup and how it looks. I don't know if you guys have built these type of setups before. If you have, please comment on it. But I don't know if I've ever seen an 18:1 compression ratio done on a GX 200 or a Predator 212 engine, getting that out of a 14cc head. So kind of presents its problems. Is definitely going to have some valve shrouding. I won't really know how bad it is until after I do the welding first, bring this to the machine shop, get the seat installed, and then really take a look at what we have. If you see this ring here, what that ring represents is the head gasket. And you can see how the outside of that seat, so it's going to be, there's not going to be any way for me to remove material to unshroud it. And enabled for me to get to 18:1 compression ratio, I need to fill all this area in with weld. I need to take this from 14 down to 10. So I need 4 cc's of material in this area. Now you might say, well, why 10? Because, you know, if you divide 212 by 10, that's 21 to 1 compression ratio. But you have to remember, the head gasket itself has volume. So you have to take the volume of the head gasket plus the volume of the head, plus area above the piston. In this situation, he has the piston at 0 deck. So just wanted to put that little video out there about valve shrouding. I know I've talked about it in the past, but this is just something that happens, and this is something real that you need to know about if you do, in fact, choose to design a head. Make sure you choose your build wisely. Sometimes things that sound good, like a completely high compression ratio and a big valve, you know, if you overshoot something, like put too big of a valve and go for too high of a compression ratio, you end up with these type of problems. So just like in anything, knowing how to build an engine is more than just picking out radical sounding parts. So till next time, hope you guys learned something from this. Hope you guys like this video. I'm Paul from Paul's Carts. My telephone number is 781-492-7358. Please comment below. All comments welcome, and thank you. And until next time, have a nice day.